Okay guys, we're going to we're going to start our next topic, which is net forces. So we started our whole unit on force and motion. We just talked about our different kinds of motion, speed, velocity, and acceleration. Now we're going to start talking about our forces. So the first thing we need to talk about are our net forces. Okay, this is probably going to be one of the simplest topics that we talk about. After this, we will go into Newton's laws. Okay, so our net forces are going to be all the forces that act on an object. Okay, so a net force, if the net forces are not equal, if there's a stronger force on one side of the object that's pushing it, and the force on the opposite side is not strong enough to push back with the same force, then yes, it can cause motion. Okay, so what that means is what we're looking at, is it balanced or unbalanced? Okay, balanced force are going to be equal forces acting on the object. Okay, so when we have balanced forces, we are going to have no motion. Okay, we did an example in class where I pushed against the wall. The amount of force that I'm pushing against the wall is pushing back with that same amount of force, and that's why neither one of us go anywhere. Okay, so we have a balanced force. When we have unbalanced forces, we're going to have an unequal amount of forces acting on an object. Okay, so when we do have unbalance, yes, we are going to have motion. Okay, and our motion is, we've already talked about this, but our object will always accelerate. Okay, always accelerate when there are unbalanced forces. Okay, so here it asks, the change in motion is means of acceleration. What is acceleration? Okay, we've already done acceleration. Acceleration is motion, we're moving. Remember, acceleration is a change in speed or direction, and our velocity is speed plus direction, so it is velocity. Yes, we are changing our motion. We're speeding up or slowing down or changing direction. Yes, we're changing our direction. Okay? All right. Okay, does a net force cause you to accelerate? Yes, it can, like we talked about earlier. If the amount of forces acting on the object are unbalanced, then yes, it's going to allow us to accelerate. If we're balanced, are we going to accelerate? No, because we're not going to be moving. We're changing direction. If we have unbalanced forces, yes, we will accelerate. We will either speed up, slow down, or change direction. Okay, so we have this example here. It says, are the vertical, the up and down, forces acting on the wagon balanced? Yes or no? Okay, this is how we know. We have the same length in our arrow. Okay, it doesn't give us a number, but it gives us the same length. So therefore, yes, they are balanced. Okay, and how we can tell is because our arrows are the same length, which means we have the same force. Okay, we have equal forces. Okay, are the horizontal forces, the side-to-side forces, are they equal? No. Okay, we see friction is pushing back on the object, the wagon, to the left, but the mom is pushing on the object from the right, and her arrow goes all the way here, and friction only goes here. So therefore, the mom has more force. Okay, so they are not balanced. Okay, and the mom's arrow is longer. So they're unbalanced. Okay, it says, will the wagon move when she pushes it? Yes, because she has more force. What direction will it move in when she is moving? Okay, she is pushing to the right. Okay, so it's going to go to the right. If she stops pushing on the wagon, what will happen? Okay, because of friction, and she's not overcoming friction, it will stop. Okay, it says draw a force diagram for the wagon when she is not pushing on it. Okay, so when she is not pushing on it, then we would have our square, and we would say our forces are equal. My arrows, if I could get them as long, equal amount, okay, equal length, that means that they are balanced. They're not going to move in it. Okay, when she stops pushing, will the wagon still move? Okay, no, because our forces will be equal. Okay, what direction is the wagon moving after she stops pushing it? Okay, after she stops pushing it, okay, it won't move either way, okay, because it stopped. Okay, it says draw the force diagram for the lady pushing the wagon. Okay, so again, we have a short arrow for friction, and we have a really long arrow for the mom. Okay, she has more force, her arrow is longer. Okay, draw the force diagram when she stops pushing the wagon. So again, it should be equal. If I can get it. Okay, all right, so let's do some practice problems. Okay, it says the diagram below shows forces acting upon an object. Which objects could be moving to the right? Circle all that apply. Okay, so here we see that all of our arrows are equal, so we're not going to move up, down, right, or left. Here it's only showing us forces going up and down, and they're equal, so there it's not going to move up and down, but we're only looking for if it's going to move to the right. Okay, here we have a force that's moving to the right, but all of our arrows are equal length, so it's not going to move. Okay, oh, actually it is going to move to the right because, excuse me, I'm sorry, it doesn't have another force pulling it, balancing it vertically, or horizontally, excuse me, so this one will move to the right. Okay, it will not move up and down. This one has a force moving to the left, not the right, so this one's going to move to the left. This one has a force going left and right, but you can see that our left force is stronger than our right force, so this object will not move to the right either. So we should only have C. All right, so let's calculate our diagrams. Okay, when we have two forces pushing against each other, we're going to subtract. So here's our example. It tells us 4 newtons. Newtons, let's write that up there. Newtons are our units. Okay. Okay, they're a unit of force, and that's because Sir Isaac Newton came up with it, and we're going to talk more about that when we get into his laws, but that is what that N stands for. It stands for newtons. Okay, so we do 4 minus 2, we get 2 newtons left over. Okay, the net force is directed, so we know we have unbalanced because we don't have 0. Anytime we don't have 0, we mean we're unbalanced. Okay, excuse me. So we do have an unbalanced force, okay? And because we have more force going to the left, we're going to move to the left. We're going to move this direction. Because we don't have 0, we are unbalanced, okay? Is the object accelerating? Yes, because it is moving. It's moving, it's changing its speed, so therefore, yes, it's accelerating, okay? Let's go over here to this one. We have 10 newtons and 2 newtons going in the same direction. So now they're moving together in the same direction. So now we're going to add the 2. Okay? So now we're going to do 10 newtons plus 2 newtons, which equals 12 newtons of force, all going to the right. We're unbalanced because we don't have the number 0, and yes, we're accelerating because we're moving. Okay? Here we have more forces that are acting together again. So we have 4 newtons plus 2 newtons because they're on the same side and they're working together. Okay? Up here this was pulling and this was pushing. Okay? Here they're both pushing. So we should have 6 newtons. They're working together to go to the right. Yes, they're unbalanced because we don't have 0, and which means since we're unbalanced, we are accelerating. Right here, we have 5 newtons pushing to the right and 5 pushing to the left, so they're going against each other, so we subtract. So we should get 0 newtons. Okay? Because we get 0, that means we're not going anywhere. We're balanced. Okay? So we're not going to move, and we're going to be balanced. And since we're not moving or changing our direction, we are not accelerating. Okay? Right here we said we have 8 newtons going to the left and 10 newtons going to the right. So they're working against each other. So we're going to subtract. Okay, so now we know that we have 2 newtons of force, net force. Okay, our 10 newtons obviously are more than our 8, so we're going to be going to the right. Okay, and we are unbalanced because we did not get 0, and yes, we are accelerating because we're moving. All right, now we have these two working together. So we total these two together, so we have 7 newtons on this side, and we have 10 newtons on this side, and they're working against each other, so we're going to subtract. We get 3 newtons. Okay, our 10 newtons is stronger than our 7 over here, so we're going to be moving to the right. We are unbalanced, and we are accelerating. Okay, so let's do some vertical ones now. Okay, so now our net force is okay, so now we have some vertical and some horizontal. Okay, so let's go with our vertical first. Okay, we don't have anybody acting against us here, so we're going to have 10 newtons going to the left. So we have 10 newtons left. And then here we're going to subtract because they're working against each other. So 40 minus 40 is 0, so we're not going anywhere except 4 to the left. Okay. Will the motion change? Well, our motion will not change because nothing is acting against us, so it's not going to change. Okay. Will it accelerate? Well, since the motion is not changing and it's still going with the same amount of force, then it will not accelerate. It's going to stay at constant speed and it's not going to change direction. Okay, here we don't have any forces going horizontally, only vertically. Our forces are moving, we have 20 and 20, and they're moving against each other, so we're going to subtract them, so we should get 0 newtons. Okay, so are we going to go left, right, up, or down? Okay, we're not going to go any of those because we have no force on either side here, and we just balanced out our force here, so we're not doing any of those. Will our motion change? No. Will we accelerate? No, because we're not changing our motion. All right. Here we have 40 newtons and 25 newtons. They're working against each other, so we're going to subtract. We should get 15 newtons. Okay. Our 40 newtons are obviously stronger than our 25 newtons, so we're going to be going up. Yes, our motion is going to change. Are we going to accelerate? Yes, because we're changing our motion. Okay. All right. Here are the 4 I want you to practice, and we will discuss on Tuesday when we come to class before we start working on our classwork. Remember, if you have any questions, please come to tutoring.